Hello, and welcome to my first in a series of videos to show you how to use Siemens NX along with ANSYS CFD, specifically ANSYS Fluent, to analyze a pod. So in our case, our structural team, specifically the aerodynamics team, gave us this shell as a candidate for our pod. So in order to analyze this, we have to fill this in and make it continuous so that we can bring it into ANSYS. The first option that we're going to want to do is to bridge the curves, because in ANSYS we're going to want a 3D shape, and this shell here is not sufficient. So in order to do that, we can use bridge curve, and bridge curve basically allows you to continuously fill in a curve. However, we don't want this to be continuous, we want it actually to be a straight line. We could do a line, however, that is less likely to be continuous, as in completely bridging the gap. So we use the bridge curve option. Next, we are going to want to fill the surface in and make it a full shape so that we can later on make it a 3D shape. So to do that, we select fill surface, and here we can see that it also does continuity, and it makes it perfectly continuous along this edge. However, we once again don't want it to be completely continuous, although this does look very nice. So, just to show you what our pod looks like, it has a flat back. So we're going to want to incorporate this into our pod. Fill surface does have the same ability as the bridge gap, as in to not be continuous. So we're once again going to just select the three curves and make sure that our default edge continuity is set to position. And this is going to try and just create a continuous shape. It won't be matching second order or first order continuity. We're going to do the same thing with the bottom of the pod. Now if you notice the asterisks, they show you where you don't have a complete connection. So we're going to just complete those to make it a full side, and we're going to apply once again with default continuity set to position, and we're going to increase our tolerance just a little bit so that it will actually create this shape. Once again, it seems like this tolerance isn't big enough, so we'll double check, make sure all our edges are selected. They are. So we'll increase tolerance just a little bit more. And this should be sufficient. Let's find out. Just to see. And there we go, it works. And it's all within tolerance, and from my looks at it, it looks fairly sufficient. It will suffice for what we want. So we're going to apply. Now we have a full 3D shape, although it is not solid yet. It's still just a bunch of shell elements. So to do that, we are going to use the sew option. And the sew option on a completely enclosed 3D body will create a solid body out of those 3 sheets that we have here, or 4 sheets in our case. And as you can see, this is now a full 3D object. And if we go to show and hide and show all non-solid bodies, which the option does not even appear, we can double check and say, okay, this is a 3D body, exactly what we want to bring into ANSYS. Now, ANSYS does not simulate, this is not how ANSYS Fluent works. ANSYS Fluent is expecting the air domain. So to do that, we're going to create the environment that our pod will be running in, which is a tube running down the axis of the pod. And so we're just going to create a plane for this and apply a circle. Not how I want it, so we'll create a sketch quick. There we go. And now we can create the circle. And we're going to make it a little bigger than what it's supposed to be. I have the dimensions written down. We also know that it's going to have a floor on this tube. We're just going to make this to be a flat floor by using this option. Next, we're going to specify some of our dimensions to make this the right shape. So for this one, we have this in metric, Not quite. Sorry, I forgot my 0. There we go. This is our dimension of the tube. Next, we will want to move this over and move the floor to where it's supposed to be. There we go. And we will now set our floor width to be the proper length. So let's just continue with creating our pod, the shape of the tube. So here I'm just using dimensions that SpaceX has given us for the tube. And just to make this more accurate, we have to specify how far off the base of the tube we are going to be. This is just the height of our suspension system. For this simulation, I'm going to be assuming our suspension system does not have any significant effect on our pod. Of course, this and the I-beam are both two assumptions that I'm making in this simulation. And ideally, you'd want to incorporate and eliminate as many of the major assumptions that you make. However, I don't believe any of these will be major, so we can ignore them. Next, I'm just going to clean this up a little bit, and we should be good to go to extrude this. So once again, I'm just going to be incorporating some space in the front of our pod and in the back in order to allow the air some room to first initialize before it encounters our pod, and then to even out at the back of our pod. So this is a bit much. We don't need it quite as far in front of our pod. It's not quite enough, so I'm just going to set it, that's a little bit better. And now I need the back of our pod, and I will set this to be not that, forgot my positive sign there, and that should be sufficient. Next, we're not going to be combining our pod in this stage. We're going to be doing that later. I'm going to make the back a little bit bigger actually, because we need to allow the air some space to equilibrate after it leaves our pod. And hit OK. As you can see here, we now have a solid tube in which we'll be running down, and this will be our air domain. Next, we need to cut out our pod, and in addition, we'll apply some symmetry while we're at it. Symmetry will just reduce our problem size and make the simulation a lot quicker. You should always employ symmetry where you can. So to do this, we are going to create a sketch on the midplane here. If I can't get there, we'll just show all the coordinate systems so I can select one. And let's see, let's use one of these. And so now that we have a midplane selected, we can create a rectangle that encompasses this entire shape. So to do that, I will just do an arbitrary large shape with 2 points. So let's just go over here and down here. Now we have a rectangle that goes through the middle. We're going to extrude it out one side. So we'll just set this side to 0 and set this to what it is and hit Boolean and subtract. Oops, other way around. We'll do this later. We'll just hit OK, and there we go. We now have gotten rid of that part of it. So if we just hide everything except for our bodies, you can see a pretty nice shape. Next, we just have to remove this from this and the cylinder. So to do that, we'll do a subtract, and that'll be our tool. This will be our body, and now you can see we have a very nice clean shape. So this looks great and is ready to go all the way to FEA. In the next part of this series, I'll be showing you how to set this up in ANSYS, as well as go through the simulation. Thank you, and goodbye.